Hey Morgan, okay, looking at number 19, it says that all gases have the same pressure. So if you have 32,680 pascals, if every single gas has the same pressure and there is, right, carbon dioxide, oxygen, and argon, then there's three gases that make up all of those pressures. And so if all of those pressures have to add up to 32,680 and each one is the same, then really you could just divide this by 3 and then you would get the exact same partial pressure for each one, and then when you add all three of those together it would add up to the 32,680. For that last one, let's see if I can get rid of all of this stuff here. Okay, for that last one, it says that the partial pressure of water vapor, right, H2O, is 139.0 millimeters of mercury. It says 18% of the total pressure, right? So this is 18% of the total pressure. What is the total pressure in the greenhouse? So really it's kind of like a problem-solving thing, and you got to think, okay, total percentages. So if 100%, right, makes up our total, and you take that and 139 of it, it makes up 18%, then you know that if you took the total value, right, if you took the, oops, that's an O, if you took the total pressure, right, and you multiplied that total pressure by the decimal form of the 18%, it would equal 139.0 millimeters of mercury. So really, when you're looking at that total pressure, kind of think of that as a variable in an equation. So if I divide this whole side by my total pressure, oops, I don't want to do that. I want to divide my whole side by 0.18, right, so they cancel. So if I take 139.0 and divide it by 0.18, that will give me the total pressure of the entire gas. Hopefully that makes sense, and you were able to now complete those problems.